Hello YouTube, this is Eli, the OBD Tech. This is part 3 of this 2004 Dodge Ram 1500 truck. Unfortunately, the check engine light came back after 2 weeks and a half of driving. It came back with one permanent code and two pending codes. The permanent code is a P0440, and the pending code that we have is, which is our two pending codes, which is the same one as a P0440 and this new one, P0441. Evaporator emission system purge flow incorrect. So as you can see, that P0456 that we had in part 1 of this evap diagnosis is a fix. It was fixed by replacing the evap purge solenoid, which was leaking vacuum. So but as you can remember, that in part 1 I also mentioned that that I was going to warn the customer that this P0440 may come back. It came back after, like I said, 2.5 weeks of driving. It came back with the new code P0441 alongside the P0440. But I'm not sure if this problem was already there during my part 1 diagnosis, or if this problem is it's a new problem, because if you think about it, it's a pending code, it's a P0441. It's pending, but the permanent code is a P0440. So I'm not sure if this is a new problem after 2.5 weeks, or if this problem was already there. But like I said, I've already did a pre-diagnosis. I have determined that the vent solenoid slash natural vacuum leak detector switch is the faulty component. And also on the repair manual, it said that the most common component of this P0441 is the natural vacuum leak detector switch. So so the next thing I'm going to show you guys, I'm going to show you guys my steps that I took to find this problem, which is the vent solenoid slash natural vacuum leak detector as the main cause of this P0441 pending code. All right. So the easiest way to test this natural vacuum leak detector switch slash solenoid vent valve is to use a vacuum pump and a voltmeter. On the vacuum pump, you need to attach the adapter to the bottom canister hose, which routes all the way to the into the evap canister. And then you got to apply at least 3 to 5 strokes, and that should create about an inch of H2O. By applying that 1 inch of H2O, the natural vacuum leak detector switch should close from open to close. So now I'm going to show you my connections to the natural vacuum leak detector pump beneath the truck. So I'm here, beneath the truck at the evap canister, where the natural vacuum leak detector is located, which is right here. I have my voltmeter back probe to the middle, to the middle wire, which is the signal wire. With the key off, engine off, the voltage should be around 5 volts. So so let's take a look at it. As you can see, we're reading 5.25 volts. That's with the key off, engine off, and that's normal. Now, if I go back to the ignition with the key on, engine off, this 5 volts should jump to around 10 volts. Minimum about 10 volts. So, so I'm going to go back to the ignition switch and turn the key on, engine off. Alright. So I'm back at the voltmeter. This is with the key on, engine off. As you can see, the 5 volts jumped to 9.56. I think my battery is kind of going low, but it's still within specs. Ideally, it should be around 10 volts, but still 9.56 is still a good voltage. So that's with the key on, engine off. Now the next step is to go back to the to the vacuum pump and apply, like I said, that 1 inch of H2O. And with the key off, engine off, the 5-volt reference should drop to 0 volts. And that basically confirms that the switch on the natural vacuum leak has closed. It has gone from open to closed, which has basically sealed the whole system. So let's go to the engine bay and perform that that test on the vacuum pump. So we're here at the engine bay. So I'm gonna apply the 1 inch of H2O. If you give it between 3 to 5 strokes on the vacuum pump, that should create at least about 1 inch of H2O. So here we go. Oh, and it's normal that the the vacuum gauge does not go up. That's normal. So don't freak out or anything, but so just apply 3 to 5 strokes and the vacuum should close the switch on the natural vacuum leak detection pump. So so here we go. I'm gonna stroke it at least 5 times, and that should create that 1 inch. 1, 2, 3, 4, 5. As you can see, the needle did not go up. That's normal, but that should close the switch on the natural vacuum switch. So let's go back to the voltmeter and see if that 5 volts did go down to 0. So I'm here at the voltmeter. I'm seeing that we have a 5.26, the same voltage as before, and this voltage did not drop to 0. I applied that 1 inch of vacuum to to the canister port, and that switch did not close. So this is telling us that the switch is not functioning properly. In other words, it's stuck in a open position. Electronically, the solenoid is working, but the switch is not doing its job anymore. It's not closing the switch. So this Evap vent solenoid / natural vacuum leak detection pump is basically the cause of this P0441. Now the next step, I'm gonna show you some bidirectional control and show you guys that the solenoid, it is functioning. All right. So I'm here at the scan tool. I'm gonna command with my scan tool the natural vacuum leak detection solenoid to turn on and off, and then I'm gonna take it back to the voltmeter, and I'm gonna back probe the control wire on the solenoid. So so I'm gonna hit start, and then I'm gonna take you to the voltmeter and see you that the computer is commanding the control on the solenoid. And then I'm going to show you guys the return control, which is the ground signal, which the computer also controls, and show you that the computer is also controlling the ground. So the continuity from the computer to the sensor is basically good. So I'm going to go ahead and hit the start and show you guys the the voltages on the voltmeter. So I'm here at the voltmeter again. I bidirectionally commanded the natural vacuum leak detector solenoid to go on and off. As you can see or hear, the solenoid is clicking. So electronically, the solenoid is good. And on the voltmeter, like I said, this is power side switch. It's also pulse width modulated, just like the Evap per solenoid. The control command is fluctuating from 5 volts to 4 volts, 0 volts, 7. So that voltage is jumping around. So next, I'm gonna back probe the return signal, which is the ground signal. Now I have back probed the return signal, which is the right wire on the connector. The middle one is your signal, and the one on your left is your control wire. So this right wire is your return ground, and this voltage should be, I guess, on this natural vacuum leak detector. This one it is below 100 millivolts, but on the Evap per solenoid, the ground side was actually around, max voltage was about 400 millivolts, but on this one it is below 100 millivolts. So now let me show you. I'm gonna zoom in so you can see the voltage is fluctuating. Like I said, it's pulse width modulated. The computer is controlling the ground side. So the max voltage, as you can see, is jumping around. It goes from 40 something, and then back to 5, then 0. So like I said, this is pulse width modulated, and as you can hear, the solenoid is clicking. But the problem with this natural vacuum leak detector is the switch. The switch is stuck open.